this is for year 11 methods. We're going to look at question 4 of exercise 17a. Okay, so this is a question where we're looking at secants and we're using a secant to find the gradient of a tangent. Okay, and this is how we're going to do it. I'm going to draw a graph. Okay, we've got y equals x to the power 4, which is basically a quadratic shape, but it's flat as a pancake down the turning point. Okay, so we've got a point 216. Okay, it's somewhere over here. It's actual physical point, and then we've got some points that it says 2 plus h to the power 4. Okay, so that all that's saying is we've got another point. It's to the right of 2. We don't know what h is. H is just a number. We know it's to the right of 2. Okay, so we're going to write the x value of that being 2 plus h. So the y value would be, following that equation, instead of x to the power 4, we got 2 plus h to the power 4. So we know where this is going. It's going to ask me to find the gradient of the secant. So the secant is the linear line joining these 2 points. And the gradient of the secant is just the gradient of the line joining the 2 points. Okay, so let's find the gradient of the secant. So m of secant is given by y2 minus y1 on x2 minus x1. It's like finding the gradient of 2 points. Okay, except we have, variables. We shouldn't let that deter us. We can sort of do that. So y2 is 2 plus h to the power 4 minus y1, which is 16, on 2 plus h, x2 minus x1, which is just 2. Okay. Now, in the questions, actually helps us to expand that power 4 bracket. So we go the first terms in the bracket square and to the power 4, which is to the power 4. So 2 to the power 4. 2 to the power 3 is 8. 2 to the power 4 is 16. Okay. Plus 4x cubed. Okay. 4x cubed h. So 4 times the first term cubed. First term cubed is 8. 4 8s are 32. 32 h plus 6 x squared. Okay, x squared is 4. 2 times 2 is 4. 6 4s are 24. 24 h squared. And we've got 4 times 2, which is 8h cubed, plus h to the power 4. Okay. And we're going down below. Oh, we've still got the minus 16, sorry. Because we've got a minus 16 there. That carries over. And down below, we've got 2 plus h minus 2, which is just h. Alright. The 16s cancel each other. And if I divide both sides by h, I get 32 plus 24h plus 8h squared plus h cubed. Okay, so this is the m of the secant between the 2 points. Now, remember, looking back at this graph, remember what happens if the value of h gets smaller and smaller and smaller and goes to 0. This point actually moves closer and closer to the first point. Okay, so essentially what's happening is the gradient of secant as h goes to 0 becomes closer and closer and closer to the gradient of the tangent until it does become the gradient of the tangent. Okay, so theoretically, m of tangent is theoretically when h approaches 0, limit as h approaches 0 of h approaches 0 of 32 plus 24h plus 8h squared plus h cubed. So what happens is, as h approaches 0, theoretically, what does this approach? That goes to 0, that goes to 0, that goes to 0. So limit is 32. So the gradient, what the limit as h approaches 0 of this whole thing gives us is that the gradient of the tangent is actually 32. That's our theoretical value that we'll reach once we work this out. So the key idea is we're trying to find the gradient of the secant between these 2 points. One point we know is 216. Another point is theoretical. It's saying, okay, we're creating a point that's 2 plus another value, and it's to the right of the point of interest. But as that h that we added to the 2 goes to 0, then we get closer and closer to the actual gradient, which is equal to 32. Okay. Now, in 17b, you will learn how to find the gradient without having to use this method, but you need to understand the method by first principles, and this is essentially finding the gradient by first principles.